Next thing that we are going to do in polynomials today is to prove couple of theorems, and maybe after that look at the applications of those theorems. Theorem. I should be at 71% with color black. Let a of x belong to R of x. Let h comma k belong to R. Let h not equal to k. If x minus h and x minus k are factors of a of x, then x minus h into x minus k is also a factor. Okay, this is not true in case of integers. We have studied that in number theory. If n1 is a n1 divides a, if n2 divides a, then n1 into n2 divides a is false statement over there. However, in polynomials, it is true statement. I give you 5 minutes to think and come up with your own proof. Proof. You are supposed to prove that x minus h into x minus k is also a factor. Is that right? So the degree of this if possible, let x minus h, x minus k is not factor of a of x. This implies by division algorithm a of x is equal to x minus h into x minus k times q of x plus r of x. Degree of x minus h into x minus k polynomial is equal to 2, implies degree of r of x is less than or equal to 1. Let r of x is equal to ux plus v. Given a of h is equal to 0 is equal to h minus h minus k, q of h plus plus v implies plus v is equal to 0. Also, a of k is equal to 0 implies uk plus v is equal to 0. These two imply u is equal to 0, v is equal to 0. Implies r of x is equal to 0. Implies x minus h into x minus k is factor a of x. Now we have not got any contradiction. Therefore, let us erase the first sentence. We can start our proof from second sentence by division algorithm. Okay. Or we have to say r of x is not equal to 0 and then contradiction to this statement. I mean, it is going to end same. This is proof 1. I mean, you can do it by two ways. This is proof 1 and proof 2 by factor theorem. Given x minus h factor of a of x implies a of x is equal to x minus h into q1 of x. This implies a of k is equal to 0, which is equal to k minus h into q of k. As h is not equal to k, implies q of k is equal to 0. बराबर है? Implies x minus k is factor of q of x. Therefore, this implies a of x is equal to x minus h into x minus k into q2 of x. True. बघा समजते का? मुलांनो,
Yes, sir.
I will make it little small so that all of you can copy it. Everything on board. Start. Okay, let us do one more theorem. Let us use different color. Green. Let a of x belong to r of x. Let degree of is equal to n, which is greater than or equal to 1. Then the polynomial equation x is equal to 0 has at most n distinct roots. Now, a of x, which is looking like a0 plus a1x plus a2x square plus dot dot dot, where there are finitely many non-zero terms, is called polynomial. Maybe we can call it as polynomial, MIAL, expression. Okay, and polynomial expression may have factors x minus alpha 1, x minus alpha 2, something like that. Right? Linear factors like this or quadratic factors like this. And when I say a of x is equal to a0 plus a1x plus dot 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 is equal to 0, This is polynomial equation. Equating your polynomial to some real number, which is 0, because I mean we can always keep RHS 0, because if there is any other number we can bring it to LHS and include it in A0, right? So this is polynomial equation, and polynomial equation factorization of LHS will look like this, and it is equal to 0. Therefore alpha 1, alpha 2 are called roots of equation. Okay, roots of the equation means the real numbers which satisfy the equation, and it is RHS is 0. Therefore x is equal to alpha is a root 1. If x is equal to alpha 2 is a root, that means x minus alpha 2 is a factor of polynomial expression. That is where, I mean, technically we have to be correct. We cannot call polynomial equation polynomial expression. We cannot call polynomial expression polynomial equation. So therefore this word polynomial equation ax is equal to 0 has at most n roots. Now intuitively it is correct, but we need to write down rigorous proof of that. There could be more than one methods of doing it. I will write down complete detailed proper proof, but you also can attempt to do that. Give you 7 minutes, 8 minutes. Okay, we will prove this theorem by indirect method. Let us assume that it has n plus 1 distinct roots. We know that degree of a of x into b of x is degree of a of x plus degree of b of x. As degree of a of x is n, a of x will look like this. Correct? And with a of n not equal to 0. Therefore, that degree is existing. N degree is existing. Therefore, nth coefficient is not 0. If possible, let u1, u2, un plus 1 be distinct roots of a of x is equal to 0. Okay, 1. 1 implies a of u1 is equal to 0. By factor theorem, x minus u1 is factor of a of x. So this implies there exists a1 of x belonging to R of x such that a of x is equal to x minus u1 into a1 of x. Note, degree of a1 of x is equal to n minus 1. Why? Because you have taken out one linear factor out of ax whose degree was n. Therefore, degree of a1 of x is n minus 1. Again, 1 implies a of u2 is equal to 0, which gives us that is equal to u2 minus u1 a1 of u2 is equal to 0. Already done. One implies, or one already is implying, as u1 not equal to u2, a1 of u2 is equal to 0.
So,
Yes.
so shouldn't the degree of a1x be n because ax is n plus 1?
No. The degree of a of x is n plus 1, we are not assuming. We are assuming a of x has n plus 1 distinct roots, and those roots are u1, u2, u3, un, 1 n plus 1. Degree of a of x is given to be n. Okay.
Okay.
By factor theorem, x minus u2 is factor of a1 of x. Therefore, this implies there exists a2 of x belonging to R of x such that of x is equal to x minus u2 a2 of x. This implies a of x is equal to x minus u1 x minus u2 a2 of x. अरे समझते का? Continuing like this, we will reach a stage where a of x is equal to x minus u1 x minus u2 dot 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 x minus un into an of x. Now, degree of an of x is equal to 0. Why? Because you have n factors now and degree of each factor is 1. They add up to n, and a of x is also degree n. Therefore, you do not have any degree, or degree is equal to 0 as far as an of x is concerned. As degree of a of x is equal to n, a n of x cannot be 0 polynomial, understand this, otherwise it will make everybody 0, and then the a of x will not really have a defined degree. Therefore, a n of x is not 0. Therefore, degree 0 but not 0. Therefore, this implies a n of x is equal to k, where k is a real number and not equal to 0. This implies a of x is equal to k times x minus u1 x minus u2 dot 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 x minus un. One also is still implying that a of un plus 1 is equal to 0, which is k times un plus 1 minus u1 un plus 1 minus u2 dot 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 un plus 1 minus un. That is what is the factorization now. u1, u2, un plus 1 are distinct implies k is equal to 0. अरे समझते का? Implies a of x is equal to 0. Contradiction. Degree of a of x is equal to n. Hence, nth degree polynomial can have at most n distinct roots. Okay, so this is now absolutely correct. Everything expressed, nothing is assumed, and each and every small step written properly. Kind of proof. You might have little smaller proofs, but there, if anyway we are writing in detail, we might as well complete it up to the last detail. So I am keeping it in front of you. Right? Question. Let. I have to increase the size to 56%. Okay. Question. Let a of x belongs to R of x. Let a of x is equal to a0 plus a1x plus dot dot dot. If 1 an is equal to 0 for every n greater than equal to 3, 2 a of 3 is equal to 100, 3 a of 10 is equal to 100, 4 a of 10 is a of 30 is equal to 100. Then find a of x.
Sir, I have unstable connection, so I will switch my camera on in a few minutes.
Okay. Now one method of, okay, for every n greater than equal to 3, n is equal to 0 implies degree of, what is the degree of a of x? 1 implies degree of a of x is equal to degree of x will be
less than or equal to 2.
2, correct? So I will show you this in two ways. First, let a of x is equal to a0 plus a1x plus a2x square. This implies a of 3 is equal to a0 plus 3a1 plus 9a2 is equal to 100. So you have three equations, three unknowns. Solve them, you get a0 is equal to 100. Therefore, a of x, a1 is equal to 0, a2 is equal to 0. बरोबर ना रे?
हो सर.
असंच येतं ना? Therefore, a of x is a constant polynomial like this. Now, because I was and given you equation a of x quadratic, so there are only 3 unknowns. But if I keep writing, say for 50 constants, it is equal to 0, and I make this n greater than or equal to 51, then practically for you to solve a1 dot 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 a 49 or 50 constants using 50 equations is going to be really difficult for you. It worked for 3 and hence second solution.
Sir,
Yes.
sir, I got for A2 upon A1, I got two different ratios. So would that imply that A2 and A1 are both 0?
A2 upon A1, what? What did you get?
I got A2 upon A1 as minus 7 upon 91 at one place, and I got it as minus 27 upon 891 at one place. So would that imply that both of them are
A2
0?
upon A1, this one,
Huh.
is equal to say two different, I think so, yes. Practically, you can get anything here because actually it is 0 upon 0. But then, because you are getting 0 upon 0, you cannot say, because you are getting two distinct ratios having the same value of the ratio, you cannot say A1 is equal or A2 is equal to 0. I mean, converse little dangerous to use. But yes, if you are getting value 1 upon 5 and 2 upon 7 for the same ratio, that means there is something wrong in this ratio itself, and it is 0 upon 0 for all practical purposes. Okay, so let me second method. Consider b of x is equal to a of x minus 100. Degree of a of x is less than or equal to 2. Degree of 100 equal to 0 implies degree of b of x will be less than or equal to 2, right? Now let us use factor theorem. B of 3 is equal to a of 3 minus 100, which is equal to 100 minus 100, which is equal to 0, implies x minus 3 is factor of b of x, correct? B of 10 is equal to a of 10 minus 100 is equal to 100 minus 100 is equal to 0, implies x minus 10 is factor of b of x. B of 30 is equal to 0, implies a minus 30 minus 100, 100 minus 100 is equal to 0, implies x minus 30 is factor of b of x. Oh, good. Therefore, b of x is looking like x minus 10, x minus 30, q of x. Oh my god, degree of b of x was less than or equal to 2, and you already ended up having 3 distinct factors. Contradiction to our previously proved theorem. Any polynomial can have a distinct n distinct roots, and we have got degree of b of x is less than or equal to 2 and roots more than 3, more than or equal to 3, contradiction. If you are getting contradiction to our previously proved theorem, b of x must be 0, implies a of x minus 100 is equal to 0, implies a of x is equal to 100. Okay, this you can write for 50 factors also. However, solving and finding 50 coefficients is going to be difficult. Therefore, whatever theorems that we are developing and we have developed, you have to look an opportunity to use them wisely so that your labor work is reduced, your solution is very elegant, and there is chance of less mistakes. Let a of x belong to r of x such that a of x is equal to x raised to n minus k raised to n, where n is a natural number. Find a of k. To use factor theorem to deduce x minus k is a factor of a of x. Now I won't give you any time because this is very easy. A of x is equal to x raised to n minus k raised to n. This implies a of k is equal to k raised to n minus k raised to n, which is equal to 0. Implies x minus k is factor of a of x, and there is nothing to do. Can we find out the second factor? Yes, x raised to n minus k raised to n is equal to x minus n, x minus k inside bracket. X raised to n minus 1, method of forcing factor. X we want to produce x raised to n, therefore x raised to n minus 1. In process, we have produced minus k x raised to n minus 1. We don't have anybody, therefore plus k x raised to n minus 2. In a process, we have produced minus k cube, k square x raised to n minus 2. We don't have anybody, therefore k square x raised to n minus 3 plus dot 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 plus k raised to n minus 2 x raised to 2 x raised to 1 plus k raised to n minus 1 bracket complete. K raised to n minus 1 minus k is k raised to n. That is what is your second factor. So if x raised to 7 minus say 2 raised to 7 is equal to x minus 2 is a factor, and you have x raised to 6 plus 2 times x raised to 5 plus 4 times x raised to 4 plus 8 times x raised to 3 plus 16 times x raised to 2 plus 30 times x raised to 1 plus 64. Something like this. Do you understand?
Yes, sir.
Next, let a of x is equal to raised to n plus k raised to n, where k belongs to R and n is odd natural number greater than or equal to 3, right? Find a of opposite of k. चला करा हो गया. I am assuming here that everything above is complete. This is equal to 0. X plus k is a factor of a of x, and another factor will look like x raised to n minus 1 minus k times x raised to n plus 2 plus k square times x raised to n minus 3 minus dot dot dot. Last one will be plus or minus depending upon n
Sir, last one would be positive.
plus,
Then is odd.
yes, plus k raised to n minus 1. Okay. Next problem. Let a of x is equal to x raised to 200 minus 1. Find all possible divisor polynomials. Of the type x raised to k plus or minus 1 of a of x, where k is natural number. Have you understood? So, for example, I can give you one. X minus 1 is a factor of this. X minus 1. Why? Because if I put x is equal to 1, a of x becomes 0. Therefore, x minus 1 is a factor. Like that, you have to find out all possible factors and tell me the number. Show me the number of divisors. Okay, I am interested in looking at that number. How many factors have you got which look like x raised to k plus minus 1? So,
Okay, sir.
as far as x raised to 200 minus 1 is concerned, there are 21 divisors of the kind x raised to k plus or minus 1. We will discuss this, how have we arrived at 21, once again in the next lecture.